Alright, today we're going to talk about simplifying radical expressions. And I want you to think of, when you hear or see or hear the word radical, it's basically a square root. And there are many different types of radicals. You can have cubed roots, fourth roots, fifth roots, things like that, but in this chapter we're just going to focus on the square roots. So let's take a look at some properties here. If you multiply two numbers together inside of a square root, so for instance 4 times 25 inside of a square root, we know that that comes out to 100, and then the square root of 100 is 10, since 10 times 10 gives me 100. But we can also split up the radical this way, where I can take the 4 times 25 and set it up into two different square roots, or two different radicals, and say the square root of 4 times the square root of 25. Almost like taking it, factorizing it, and then the square root of 4 gives me 2, and the square root of 25 gives me 5, and then 2 times 5 gives me 10. And that's a property that we can use all the time with square roots. Same thing when we're dealing with quotients, or when we're dividing. So 36 divided by 4 inside gives me 9, and then the square root of 9 gives me 3. But we can also look at those separately and say, okay, well, the square root of 36 over the square root of 4 gives me 6 over 2, which also gives me 3. So we're going to use those properties today to simplify radical expressions. Now, to simplify radical expressions, or just when you're given a square root, you want to try to look for things that will give you a perfect square. So for instance, I know that in the square root of 18, I break it down like this. I know that this is the square root of 2 times the square root of 9. Alright? And I don't know the square root of 2. I mean, we can get a decimal approximation, but I do know the square root of 9 is 3. So the simplified version of this answer is 3 times the square root of 2. And that is the simplified version. And I know some of you are thinking, well, what if you didn't recognize that 9 was in there? Well, let's say you started with two different numbers, so like the square root of 3 and the square root of 6. I can't break down 3 anymore, but I can break down 6 one more time into the square root of 2 and the square root of 3. And what this turns into, if I did a long chain, would be the square root of 3 times the square root of 3 times the square root of 2. Because if I multiplied all those numbers together, 3 times 3 I get 9, times 2 brings me back to 18. So we just split this up. But if you take the 3 times 3, you get 9. And we know the square root of 9 is 3. And we still get the same answer that we got before. So whenever you multiply two things together, like if I took the square root of x times the square root of x, I know that this is going to come out to just x. Okay? Because, for instance, we just saw that with the square root of 3. The square root of 3 times square root of 3 is the square root of 9, which comes out to just the thing that's on the inside. So you can do these a bunch of different ways. If you look at b, no numbers involved, but we can take out certain things here. I know that I can break up x to the 4th like this, since x to the 2nd times x to the 2nd gives me x to the 4th. And I could break up y to the 2nd, or 3rd, sorry, like this. Y to the 2nd times y to the 1st gives me y to the 3rd. And I can simplify this now. I know that this comes out to x, because remember, square roots and squares just cancel each other. That means this will also be just x. And then y to the 2nd cancel. We get y, and then I have a y left over. That has to stay in there, because I can't just take the square root of y. So really we have x to the 2nd times y times the square root of y for that. Okay? There are different ways that you can go about getting that answer too. Some of you would know it right away. You'd say, oh, well, I know that if I look at x to the 4th, I know that right away that that's x to the 2nd under a square root. You can do it that way. So a bunch of different ways. Same thing with this. You can do this in fraction form as well. Real quickly, I could separate this to the square root of 5 over the square root of 9. I don't know the square root of 5 off the top of my head. It's not a perfect square, but I do know that the square root of 9 is 3. So I could leave that one just like that. And then what I would do for b is do a little simplifying inside first. I have 1a on the bottom and 5 on the top being multiplied, so I can cancel this one out with one of these, be left with 4. So the square root of a to the 4th is 8 to the 2nd, and the square root of 81 is 9, and you can leave it just like that. Right. Lastly, just pretty much the same as what we had before, just two fractions. So a couple different things here for like this one. We'll talk more about that tomorrow. We'll just do a here. 80. Let's say we wanted to break that down. We know the square root of 25. That's pretty simple. So we get something over 5. But let's say for 80 we didn't know how to break that up. Maybe 20 times the square root of 4, which is fine, we can do that. But then I know that I can break 20 down even further. That's the square root of 4 times the square root of 5. So that's my 20, but then I also have another square root of 4 here. Well, if I combine those two, I get the square root of 16, which gets me back to 4. So really the top there is 4 times the square root of 5. So 4 square root of 5 over 5. So we'll talk more about some of this stuff tomorrow, but just wanted to give you a brief intro into simplifying square roots and radicals.